So, hello everyone. Nice to see you all here. So, my name is Johan, and in this session I'm going to talk about Java's hidden gems, tools, and libraries. Basically, this talk is based on a GitHub repository with a lot of tools and libraries, like 70 or something, with a lot of examples in them. I will share that one as well, and I will cover some of them in this session. If you're interested, then later at home or on your phone in public transport, you can look up the other ones if you want. It's just simple examples. And the whole idea of this talk is basically to inspire you. If you see a tool that's interesting, I won't do a deep dive into that tool. So if you think it's interesting, simply look it up on the internet, maybe watch a video on that talk, but at least you know the tool exists. So if you want to contact me later, feel free to approach me. All the examples are on GitHub, so if you go to github.com/myname, you can find it. You don't have to type the last part, then you can just click. And I divided the topics in 5 categories, the tools, so we'll quickly go over them, but let's simply do that in the IDE. But I need to grab my list. So first one is actually ArcUnit. So with ArcUnit, we can sort of create JUnit rules, or not sort of, exactly JUnit rules, to check the implementation. For example, here we see that we define a rule, and we say, for example, that all the classes that are in the controller packages, which have the address controller annotation from Spring, should have a name that ends on controller. That goes wrong because I have one controller which is wrongly named. And of course, that should be wrongly named controller. Then it would work fine. But with this runs as your normal unit test. It will continuously check if you adhere to the architecture that you defined. So you can also do some more complex stuff. So for example, any classes in the payment package can only depend on classes in the common package, the Java packages, or the Spring packages. The payment classes cannot depend on, for example, the classes in the user package. That way you can define entire rules about your architecture. So for example, from common, I'm only allowed to use common stuff, or from the frameworks. And I can even define them. So I can define the layers, so all the classes in the controller package. I can basically name them controller layer, same for service, and then I can say, okay, the controller layer cannot be accessed by any layer. The controller is only accessed by the front end in JavaScript. The service layer may be accessed by the controller layer. That way you know for sure that everyone adheres to your architecture. Because in the beginning of your project, you define an architecture, then people start working on it, and after a year, someone is like, yeah, this probably fits here, it's easiest, and then you start deviating from your architecture, and this automatically basically makes sure you don't do that. Then we go to another tool, it's Awaitility. So normally, if you do something asynchronous, and you want to check for the results, so you call a method, but you don't know exactly how long it takes, then you can do a thread.sleep, like in this example. And after that, you can check if the result is there. But that's, of course, a bit ugly. Maybe on some machine, you need to sleep like 2 seconds, and maybe on the build server, you should sleep for like 5 seconds, because it's slower or more stuff is going on there. So it's a bit of an ugly solution. Instead, we can use awaitility, and we can say, OK, await at most 2 seconds until certain conditions. So in this case, I simply check if something is added to that list, and then I can do my asserts. So this way, it's way quicker as well. The build time improves as well. Then we come to the Jacoco agent. Who here knows Jacoco? Probably most of you, if you're a Java developer, Jacoco is used to measure the coverage. But what a lot of people are not aware of is that you can also use it to measure coverage of running applications. Most people use it for their unit test coverage, but you can do other approaches as well. So how does it work? So if you want to try it out, there is a README. So I can simply start the application. So I started the application. I can go to my endpoint. And in the application, I say that I want to use the Jacoco agent. And I also specify where I want to store the coverage results. And I say things like append is false, and you should also specify which classes it should measure the coverage, because else it will also measure the coverage of all the Java classes and the Spring classes or whatever library you use. So I need a browser now. Oh, of course not like that. So it's a simple car endpoint. Returns some stuff, but that's not really the interesting part. So now the important thing is you need to stop your application, else the coverage isn't written. When I tried this, I tried it numerous times. File was continuously empty. Then after like an hour, I was like, what's this? I'm going to drink something. And when I came back, the coverage was written because I stopped my application. So make sure you don't make the same mistake as I did. So now coverage is written in some binary format, which for most people is probably not that nice to read. So we will convert it again with this time the Jacoco CLI to some HTML, which is more easy to read. And then we can go to this one, open the browser. So I can see that I touched my retrieve car method because it is triggered by the GET request on car. I didn't post anything, so this part isn't covered. So you can use this for any test you run. You can run this during a performance test. You can run this during acceptance testing. If you, for instance, use Cucumber or whatever, you can use this to measure the coverage. And we did this once in a project where we had quite well feature tests written in Cucumber, and everyone said that they should cover most of the logic. Of course, it doesn't cover the corner cases, but the main logic should be covered. So we ran it with Jacoco and found out that quite a lot of our code base wasn't touched. Or quite a lot is maybe a bit of an exaggeration, but at least some portion wasn't touched. And then we found out it was actually dead code. It wasn't called from any place, so we could remove it. So there are some ideas that you can do with this Jacoco agent. I even got the question if you can do this on production. Sure you can, but probably it has some performance overhead. Then we go to PyTest. PyTest is a form of mutation testing. So basically what PyTest does is it runs your unit test, and then it changes the production code. So let's go to the production code. That's easier. So I have a really simple example which does some checks. But what PyTest then does, it creates several mutants, so changes in the production code. So this bigger than will be changed into a smaller than, and then it runs the test again. And it might create like 8 mutants for one test case, so it will be a bit slower to run. You probably don't want to run it on each commit. But then it basically checks if your test still passes while the actual production code is changed. If that's the case, then basically you have a bad test. Yeah, I definitely have a bad test because I only check one thing. And then what I can do is I can run this command. So let's go to the right directory. And then it basically does all the mutants. There are some different ones, as we will see. You can choose which ones you want to activate or deactivate. I just run them with the default profile. And then again, we get basically like a coverage report. It's not really in a hurry today. I guess I can already open this one. So here I see which part is well covered, which tests basically survived the mutations. I can see basically which mutations were used. So for example, negated conditions. Sometimes it will, for example, replace an integer with 0 or things like that. And these are the active mutators. So these you can enable or disable. So this is a way to test the quality of your test, basically. If managers sometimes ask for 80% coverage, yeah, that's quite easy to get. You just call every method, you don't do any asserts, and it's done, right? With PyTest, you can find these cases, because sometimes it's done on purpose, but often if you do a refactoring, you forget to test one of the if branches. PyTest will notify you of that. Then we have test containers. So in the past, what often happened is you have some kind of database where you want to run your integration test against. So then you also need that database on your build server or on some other server that's centrally available. But you can also use test containers and basically use Docker containers to test against, which are started automatically in your test. So this is a really simple, pretty plain Java example which runs it. You can use any container basically. I have a MySQL one that's supported by default, but even ones that aren't supported by default, you can use them. You can use any Docker image that you want. Then let's look at some more implementation classes or libraries and tests. For example, GraphQL. I think this is also a lot of front-enders are here. I think it's more popular already in the front-end world. In the Java world, it's also gaining some traction. Basically, GraphQL is really helpful if you have like one endpoint which returns a lot of data, but in some cases you're only interested in one of the fields. For example, you have a user with 100 fields, but in one part of the application you only need the name of the user. Then if you do the REST request, it will get everything. It could be megabytes even. With GraphQL you can actually filter, so it's like SQL for your REST endpoints. So I have one REST endpoint basically, and here I say I want to have the account, and I want the ID and the number of the account. So I can check that I get these back, and I also check that I don't get the user back, because I didn't request the user. Then when I change my query, so here I say, okay, I want to have the same information, but also from the user I want the first and the last name. So I run this again, and then I can actually retrieve those values. Of course, the back-end implementation is a bit more complicated than a simple REST application, but this allows you a lot of flexibility. Who was recently approached by a recruiter? No one? Are you all bad developers? So if you, after this conference, think like, that tech stuff, I'm really done with it, I want to do something else, I will explain you how to become a recruiter. So we create a template, HTML template, with basically some special characters in it. You got these probably right. Hello, would you be interested in this vacancy? We expect this kind of knowledge, and we offer you some salary. Then in handlebars, I can basically configure all these things. So I can fill in all these fields. So let's simply run this. I output it simply to the console. You can also output it to a file or to an email or whatever, but I leave that up to you. And there's also an alternative. It's called Pebble templates. It's even more advanced. But yeah, here you can see basically it fills in all the values. Now you know why the recruiters never put your first name in it. It's basically because they use templating and forget to fill it in properly. Here you see all the stuff that you need. Only 54 hours a week, and for a really good salary. So without kidding, I mean, if you want to do HTML templates, and you often need these things in an application because you probably send out some mails by the application, then this one can be really helpful to quickly set that up. Then we go to Java Poet, which I need to show it only based on the name. I mean, it's an awesome name, of course, for library. So let's say we don't want to write a Java class in the normal way. So normally you write your Java class. We generate it automatically based on Java code with Java Poet. So we will generate this one, simply student class. And we do this on this way. So we add a setter, a getter, a constructor, and then we create a class, and we build it, and we print it. So this way I can dynamically generate my classes. Now you're maybe thinking, okay, what's this? Or you're thinking, I'm going to do this next Monday to annoy my colleagues. One of those two. So for normal applications, this might not sound really useful. But if you create like frameworks that are used by other applications or libraries, then this tool is actually used a lot. So if you ever have the need in your company to create some kind of library or tool where you need to dynamically generate classes, then keep this one in mind. Then one where I also always doubt if I should actually show it to you, because actually it might make my life more difficult if I show it. You probably know these websites, right? They ask for your phone number. You don't really want to fill it in, because then people start calling you, and at least I don't like that, especially if it's for recruitment or sales or things like that. So I fill in either a fake one or no phone number at all, and then I'm a happy developer. With lib phone number, you can actually check if the user entered a valid phone number. So here I enter a phone number, I can parse it, and I can check if it's valid. But I can also check from which location it is. If it's a landline, you know these phones we had in the past with a cable attached to it, you can find out which location it was based. For a mobile phone, you can also find out the carrier and the country of it. So you can find out all kinds of interesting details. And it works basically in any notation. So this notation works, this one, this one of course not, it's an invalid one. So this allows you to validate your phone numbers. Then the next example is TimeFold. It was called OptaPlanner in the past, but basically it was sort of renamed. With TimeFold, we can do all kinds of scheduling stuff. So for example, to schedule the optimal route to deliver packages. So any scheduling you can do with this. What I did, I basically used it to schedule a conference, schedule the sessions of the conference. So I can define some constraints. For example, a room has only one session at a time. It's a bit annoying if there is another speaker next to me talking about another subject. Then the second one is also that a speaker can teach only one session at a time. I mean, some speakers like Venkat, they seem to be everywhere at the same time, but most speakers are only at one place at the same time. If a speaker has multiple sessions, he or she prefers to stay in the same room, because then he's used to the setup. It's a bit easier, basically, to make it nicer. We have some speakers that have multiple sessions. So they are basically great. And for that, we want to punish them. So we will give them all the sessions back to back in the same room as an extra challenge, basically. And then it could be that at a conference, you have sessions in different languages. Here, we could maybe have sessions in Dutch and sessions in English. We want to separate them in separate rooms as much as possible. So this is just like plain Java that we write these rules in. So a bunch of classes. Some things go wrong here, but that's actually on purpose. So you see two sessions here in the same slot. That's basically because I have too many sessions for the number of rooms. So it will show you that it couldn't find an optimal plan, and you need to check that, basically. Terminate that one. And then some time ago, sometimes you have issues with dependencies that aren't really secure, that have security holes in it. And you can actually check that with the OWASP dependency check automatically. It downloads all kinds of security issues from the internet and then checks if any of your dependencies has an issue which is covered in that list. So now it will go over my dependencies, and it should quite quickly show what went wrong. It also creates an HTML report, but we can also see it here. Apparently, I use log4j. No idea what the problem is with that, but maybe you know. Then the last one. So you probably, or maybe use Maven, maybe Gradle, but a lot of people still use Maven. If I Maven compile something, it takes quite a bit of time. It needs to compile everything, slow, slow. Still not done. OK, actually something went wrong. That was not what was expected. OK, one failing demo at the end is OK, I guess. So I advise you to have a look at, for example, Maven Daemon. With Maven Daemon, you have quicker builds of your Maven application, or use the Maven cache extensions, which caches and also improves your build time. That will greatly reduce the build time on your laptop, but you can also use it on the build server. There's one good reason not to use it, and that's you get less time to drink coffee. But I mean, every advantage has its disadvantage, right? So that was it, and really quick. If you want to look at the other examples, as I said, there are like 50 more or something like that. Look them up there. Unfortunately, we're running out of time, so I can't show you any more at this point in time. And I wish you a great rest of the conference.